Come all you moonshiners if you want to hear.
Well, welcome back. I'm George, and this is the final in the series of the 240 volt, 20 amp PID controller. That's proportional, integral, and a derivative controller. So, sit back, and we're going to explain everything you absolutely need to know, and we're going to bring it all together from all of those where we started, and we cut the box, and we attached all of our accessories, and then we wired all those things, and this one here is going to bring it all together. You ready? I hope so. Now, if you purchase a PID from me, of course, you're going to get the instructions that go with it. I'm just going to send those to you anyway. But, yeah, I don't hold me responsible for who and how they wrote these. I'm going to demystify every bit of this for you here in just a few minutes. This is a PID controller. Now, of course, we've got our probe already connected. Because remember, if you turn this on without a probe, what's it going to say? ORAL. Or don't call George because you just forgot to plug in. It's not going to work. Okay, it's got to have a feedback mechanism in order for it to operate. Now, when we turn this on, oh, you see all kind of crazy things start to happen. Now, all these numbers start to flash in and stuff. You'll notice like at 247 volts and 0 amperage. That's again, we don't have a load over here, so we're not drawing any power, so it's not going to read any amperage. The PID itself is reading 19.2 degrees centigrade. We need to change that because I like working in Fahrenheit, and if you like working in centigrade, leave it. But I'll show you how to do that. And with the set value right now is 50. So it's working hard. You can see the small little red light here. That's the outlight. That means that this PID is sending a signal to that solid state relay to make this thing hot. But there's nothing there to draw, so but it's still hot. So when that light goes out, that means it's achieved the proper temperature. And when it's fluctuating back and forth and it's just trying to get there, you'll notice it'll flash. It may flash fast, it may flash slow, it may flash once and quit. But that's when it's doing its, and we'll talk about that. So, remember the bottom number, the green number is the set value. That's the number that you change. You tell it what you want it to be. And you use that by using these two arrows on the right-hand side, the up or down arrow buttons. And then there's one next to it, it's that way arrow, and that moves the decimal point over so that you can change each digit. Okay? And then finally, when you do that, you just push the set button and it stores that change. And the top number is the value perceived by your thermal probe. So as I'm holding this here now, you'll notice that I'm at 19.1, there's 20.4, I'm a little warm, 22.2, so it's responsive. Now, let's get into the parameters. Here's the first thing that you need to remember. And it's very straightforward and very simple. Push set and hold it for 3 seconds. Oh, or as I like to say, until something happens. And that is, the very top says IP. And you'll notice that there's nothing else on the screen but IP. I'm going to turn this off. Because that brings us to the instructions themselves. These are the parameters, and then I'll walk through this and you'll see me actually set the parameters. But I want you to understand how these parameters are actually set up. This is like a book. Think of it like a book. And this book has 1, 2, 3, 4. This book has 5 chapters. All right? So we're going to go through chapter 1, and then we're going to tell it to go to chapter 2. Then we're going to tell it to go to chapter 3, etc. Okay? And in these chapters, as a matter of fact, chapter 1 has only 3 pages. Let me get something to write with too. So, chapter 1, IP, has 3 pages. And that is SN, which is the input type, SC, your calibration offset, and DL, your digital filtering. So here's how you get there. Remember I showed you on here on the front of this? You had that arrow button that points this way? There it is. Once it says IP, all you do is push that arrow button one time and SN will show up. When SN shows up, underneath of SN on the bottom of this screen in the set value area, you'll notice in most cases, because it comes preset this way, there'll be a backwards Y. That represents a K-type. The K-type couple. You can always distinguish a K-type from a PT100 simply by the number of wires it has. A K-type has 2 wires, PT has 3. They both work extremely well. It's just one will go, I'm trying to think, 0 to 200 degrees Celsius, and the other one goes to like 600 degrees Celsius. We're not going that far. So if you're looking for something real special, maybe you get the PT100. Who knows? But in this particular case, all we're using is a K-type coupler, and they're dirt cheap. Okay, now once you get there and you have that set, you can change that. Of course, just make sure you got the right one. If by chance you have a K-type coupler attached to your PID controller and you have this set for something else, what's it going to do? Yeah, it's going to get confused. It's going to say, oh, I'm looking for a K-type signal. Oh, but he's got me set for PT. And so you get some weird numbers. So if that ever happens, if you plug it in, you get some weird numbers, check that. You probably just got it set to the wrong one. All right, the next one is a calibration offset. And that's SC. It'll always show up as 0.0 because that's, again, factory set. If you can set this is the beauty behind it. See, we're already on page 2. The beauty, you can set your PID controller an offset. You know that, oh, by the way, this thermal probe is actually 2 degrees off from my mercury my mercury thermometer. Well, okay. And the easiest way to do that is just boil water. You know, water boils at 212. You have a mercury, well, you don't even need a mercury thermometer at that point. You just drop your K probe in there. And if it's reading 213, you know it's off by 1 degree. So you go in here and set an offset, and you'll tell it, well, if it's reading 213, I just want you to say 212. So you put in here -1. All right, go to the next one, digital filtering. That'll be set at 0. And just leave it at 0. Digital filtering is something that we don't need to concern ourselves with. It's a bit complicated, but it's there for those who are in a more advanced stage of using a PID controller. Once you hit set, it'll take you right back to IP. Boom, chapter 1's done. Remember, to get from one screen to the next, all you do is just push the set button. If you make a change, push the set button. It remembers it and it goes right to the next page. So you've gone that arrow, and the way you're looking at the left arrow, push the left arrow button, goes to the first page. Push set, goes to the second page. Push set, goes to the third page. When you're done, push set. It's going to close that chapter and take you back to the beginning of that chapter. Now you're back to IP. Just push set. That's going to close that chapter. It's going to open up OP, operations. It's going to open up the operations chapter. And in the operations chapter, you also have 3 more pages. Again, push the left arrow button. It's going to bring you to the very first one. So, and it's going to look weird, but it's really CTRL, control. We put it in PID. PID, or there's also, if you scroll up and down with the up and down arrows, you'll find AT for self-tune, auto-tune, or you'll find R, factory reset, or you'll find a really odd-looking on-off, which is on-off control. So we leave ours in. Well, we make sure that it's in PID mode because we want to use it as a PID controller, not an on-off controller. That's some of the challenges that some people have because they've got it set to on-off, and then they'll call me and wonder why it doesn't work. And we'll go through the parameters and say, yeah, you set it to PID, let it do its thing. All right, then of course you just push the set button. What's it do? Goes to the next page. HC, and this one is always, they normally come set with heat. If not, there's only 2 settings, heat or cool. Change it. Push set. Guess what? Next page. Now it goes to run. That's the operation mode. We want ours to be always set in auto. We want it to automatically do what we're going to tell it we want it to do. We want it to operate as a PID. So automatically just do that. Your other options are DN, manual inhibit, a real weird looking manual mode where you can adjust the percentages of what you want your power output to be. or, of course, automatic. So we just leave it at automatic and let it run. If you push set again, you get to the end of that chapter, and guess what? Yep, it goes right back to OP. So now we finished that chapter. Push set again, and it opens up ALP. And ALP will show up on the screen. That is alarm parameters, ALP. In your alarm parameters, the first one is mode. It'll come set to 0. The two options is either 0 or 1. Alarm off or alarm on. We're not using an alarm on here, so we leave it at alarm off. Now, at this point, you can actually go through all of these and just skip through them if you want, but it begs a discussion and an explanation. Okay? So once you're here, you hit set, and of course there's no way to get back without going through all the pages. This is one of those books that once you open a chapter, you got to read them all. So we're on page 1. Hit set, you go to page 2. HIAL, high alarm limit. That's how high do you want it to go before the alarm comes on. Then you have push set again, low alarm limit. How low? And these are preset. The high alarm is 9999. The low alarm is negative 1999. And then we have a positive deviation. Push set, go to the next page. Positive deviation alarm. Remember, we talk about deviations in alarms. Do you want to put a deviation in that when it hits that alarm? Do you want it to happen before? And you want that deviation to take place. So deviation high alarm limit or push set deviation low alarm limit. That's negative deviation alarm. Push set, it goes to D. And then we hit set again. Guess what? Yep. Closes that chapter. Boom. And brings us right back to ALP. We push set again, and it opens up the next chapter. PID, proportional integral derivative. First thing we do is we push the left arrow button, brings us to CTL. That's the control period. The control period when you push yours and it opens up will normally say 4. Set that to 1. You want a low control period. If you're using a normal mechanical relay, set it to 20 so you don't burn out the relay. If you're using a solid state relay, set it to the lowest setting possible, which is 1, and that control period means it cycles very, very fast. Push set and P will show up, and that's your proportional control. Now, what proportional control is in that band of excellence, you know, you've got the set temperature, and then you've got the temperature that's being sensed. That band, the proportional band, is only looks at the error between the set value and the perceived value. Okay? That's what it's looking for. It's looking for that share. What do you want that band, how wide do you want that band to be? Do you want it to be 25 degrees or do you want it to be, or 25 increments, or do you want it to be 1? And so we set that to 1. Press set, okay? And it brings you to I, integral. And what the integral does is the integral integrates that error over a period of time. That's the easiest way to explain it, okay? So it'll take a time, it records a time during your proportional value and the differences in that error between set value and perceived value, but it does that over a period of time, and it integrates that time into the program, all right? That we set at 540. And then we push set again, brings us to D, derivative. Derivative we set to 200, and your derivative actually, it's really, really cool because it's like a buffer, okay? It takes that proportional integral and it kind of buffers it. It'll actually slow the rate of change and power to prevent overshoot, undershoot, or oscillations. That makes sense? See, that's what's so cool about this, is that with all three of those, now you can run it as a PI, or you can run it as a PI and D. And when you add that D into it, that's what works towards slowing that rate of change so that you don't have your oscillations or you don't have your overshoots, undershoots. And that's what we call, when it goes above or below your temperature, overshoot, undershoot. Once you get that set to 200, push set, and guess what? Boom! It brings you back, you've closed that chapter, and that brings you right back to PID. Push set again, and it brings you to the last chapter in the book. Unit. UNIT. Again, left arrow button, C or F is going to show up. If it shows up with a C, use your up and down arrow button and change it to F. Push set, it'll save that, and now everything will be, it'll read everything out in Fahrenheit. If you like C, leave it at C, push set, it reads everything out in centigrade. Once you've got that done, if you push set, it will return you back to the main screen, which will be your perceived temperature and your set value. Now, at any time in that process, while you're in here, if you get all, if something goes cattywampus, push set and hold it for 3 seconds, it'll go back to its normal, or just set it down and wait. Give it about 20 seconds, it'll automatically go back to its original screen where you started. And then you can start over again. So you're not screwed if you make a mistake. And believe me, go through this 2 or 3 times and all of a sudden it becomes intuitive. But I understand. You'll make mistakes, and I do all the time. I still do. You'll get through halfway through and something will go crazy. You can't back up. Just push set, hold it. It'll go all the way back to the beginning, and then when what I can do is I can skip chapters. I can get to IP, and instead of hitting the left arrow button, I just hit set and go to OP. I want to go to that chapter. No, I want to go to the next. I want to go to AL. Nope, I want to go to PID. So you can just open the chapter, but then when you push that arrow button, that left arrow button, it's going to open up the pages for you. And you can't go back through the pages. You got to go through all the pages before it goes back. Okay? Boom. That's as easy as it possibly gets. And with all of this, now that you understand this, these are the controls that you have for the process that we are using, which is heat control in a still, in that type of a configuration where you're looking for precise control, and your controller should maintain your heat in your still within, I usually say like within 2/10 of a degree. Okay? Now, let's set this one. And you can walk through it with me, and I'm going to show you. I can do it real quick, but I won't. I'll push and hold set for 3 seconds. It goes to IP. I don't have anything to set in IP. I'm just going to skip that and go to the next chapter. OP. If I push the left arrow button, you see it says control says R. Would I want that? I want that to be, there's on off. I want it to be in PID. Push set, goes to the next one. There's heat. Push set, run. It says DN. What did I want mine in? I want it in auto. Because in DN, that's in manual inhibit. So go up and down. There's auto. And then push set. It stores it. Guess what? I'm back to OP. Push set again. Go to ALP. Left arrow button. Oops, I went too far. I went to PID. I can just sit here, watch this. I'm just going to push and hold it. There, it goes back to its original screen. Now I start all over again. IP, OP, there's ALP. Push the left arrow button. Now I'm in mode 0. Push set, high alarm limit 9999. Push set, low alarm limit negative 1999. Push set, deviation high alarm 9999. Deviation low alarm 9999. DF, what was that? If you look up here, DF is by hysteresis. It says 3. I want to set that to 1. There's 1. Push set, let it go. Display. Oh, that one's not on here. Display is on. That's the display on your screen. And then I'll set it back. It goes right back to ALP. Okay, so now from ALP, I just push set one more time. Now I'm at PID. Left arrow, CTL says 4. I want that to be 1. Set. P is at 50. I'm going to increase that to 1, go left, and then decrease that to 0. There. It's set to 1. I, it comes preset at 30. So what I'll do is I just go to the left 1, increase that to a 4, go left 1, and enter up to 5. So I is 540, my integral. Push set, D says 8. I just know from experience I go over 2 decimal places, it makes it 208. Then I just scroll across until it gets back to the 8 and then drop that down to a 0. 200. Push set. It goes right back to PID. So those are already set. Now, my last one is unit. This one is set to C. I want that to be in Fahrenheit. That's F. Push set. It's saved. Push set. Look at that. Now it reads 66.9 degrees Fahrenheit. 122 degrees is my set value in Fahrenheit. Folks, it's as simple as that. So this PID is set to operate the way it's supposed to be. And one thing in there, did you notice there's one thing that they included the display right here. Somewhere in here, there was an extra page that they stuck in there, and they didn't add it to their instructions. And that's the display. You can turn the display on or off. Why would you turn the display off? I don't know. Just make sure it's, yeah, you'd never know it if it was off. Just leave it to on. All you got to do is that's just one more page. Just hit set and go right by it. Now, with all of this knowledge, okay, you've got the book, you've got the chapters, you've got the pages. We went from the very beginning. We do this. We did the cutting out, the assembly, the wiring. Now we've gone through setting the parameters and programming this to operate the way we want it to. That should answer all of your questions, and that should really send you well on your way to being able to assemble one of your own. I mean, they're relatively simple. And oh, by the way, should you have an issue, just give me a call, send me an email, or let me know. I'll build one for you. Sure, I'll just send you an invoice via email. You pay that, and as soon as you do, I'll build it, set it, test it, ship it. Happy distilling.